Hey guys, today I'm going to be doing the OWASP Top 10 2021 room on TryHackMe. So we're going to be learning about and exploiting each of the OWASP Top 10 vulnerabilities, and these are the 10 most critical web security risks. Let me turn the music down a little bit. Okay, so introduction. Okay. This room breaks each OWASP topic down and includes details on the vulnerabilities, how they occur, and how you can exploit them. You'll put the theory into practice by completing supporting challenges. Number 1, broken access control. 2, cryptographic failures. 3, injection. 4, insecure design. 5, security misconfiguration. 6, vulnerable and outdated components. 7, identification and authentication failures. Software and data integrity failures. 9, security logging and monitoring failures. And 10, server-side request forgery, SSRF. This room has been designed for beginners and assumes no previous security knowledge. We read the above. We'll complete that. Accessing machines. Some tasks will have you learning by doing, often through hacking a virtual machine. First, let's start the virtual machine by pressing the Start Machine button at the top of this task. Start machine. Connect to our network or deploy the attack box. So we'll go ahead and connect to the TryHackMe VPN. Okay, initialization sequence completed. And we have our IP of 10.2.24.111. Okay, so that's good. We'll complete that. Okay, task 3, number 1, broken access control. Websites have pages that are protected from regular visitors. For example, only the site's admin user should be able to access a page to manage other users. If a website visitor can access protected pages they are not meant to see, then the access controls are broken. A regular visitor being able to access protected pages can lead to the following: being able to view sensitive information from other users, accessing unauthorized functionality. Simply put, broken access control allows attackers to bypass authorization, allowing them to view sensitive data or perform tasks they aren't supposed to. For example, a vulnerability was found in 2019 where an attacker could get any single frame from a YouTube video marked as private. The researcher who found the vulnerability showed that he could ask for several frames and somewhat reconstruct the video. Since the expectation from a user when marking a video as private would be that nobody had access to it, this was indeed accepted as a broken access control vulnerability. Read and understand what broken access control is. Okay, complete. Task 4, Broken access control, IDOR challenge. Insecure direct object reference is what IDOR stands for. IDOR, Insecure Direct Object Reference, refers to an access control vulnerability where you can access resources you wouldn't ordinarily be able to see. This occurs when the programmer exposes a direct object reference, which is just an identifier that refers to specific objects within the server. By object, we could mean a file, a user, a bank account in a banking application, or anything really. For example, let's say we're logging into our bank account, and after correctly authenticating ourselves, we get taken to a URL like this: https://bank.thm/account?id equals 111111. On that page, we can see all our important bank details, and a user would do whatever they need to do and move along their way thinking nothing is wrong. So you can kind of see that represented in this graphic here. We have the ID equals 11111111, and the account owner is Jason Clark. There is, however, a potentially huge problem here. Anyone may be able to change the ID parameter to something else like 222222, and if the site is incorrectly configured, then he would have access to someone else's bank information. So now the ID field has been changed to 222222, and instead of the account owner being Jason Clark, it's now Nick Perry, just by changing that ID parameter. The application exposes a direct object reference through the ID parameter in the URL, which points to specific accounts. Since the application isn't checking if the logged in user owns the referenced account, an attacker can get sensitive information from other users because of the IDOR vulnerability. Notice that direct object references aren't the problem, but rather that the application doesn't validate if the logged in user should have access to the requested account in the first place. Read and understand how IDOR works, okay? Deploy the machine and go to http://1010.194.239. Log in with the username Newt and the password test1234. Okay, so let's do that. Server not found. Oh, okay, so that doesn't need to actually... Let me just copy this. Oh well, we'll just do this. Copy the IP. Okay, enter the username of Newt and the password of test1234. Log in. THM note server. Things to buy from the store. 2 carrots, 1 potato, 1 cheese, lots of chocolate. Let's see. Okay, we did that. Complete. Look at other users' notes. What is the flag? Okay. So we're ID of 1. We can look at 0 first, because that could be an admin user. And there we go. Flag 543. Okay, so there's our flag. We'll copy that. Paste that here. Pretty easy, right? Okay, number 2, cryptographic failures. A cryptographic failure refers to any vulnerability arising from the misuse or lack of use of cryptographic algorithms for protecting sensitive information. Web applications require cryptography to provide confidentiality for their users at many levels. Take, for example, a secure email application. When you are accessing your email account using your browser, you want to be sure that the communications between you and the server are encrypted. That way, any eavesdropper trying to capture your network packets won't be able to recover the content of your email addresses. When we encrypt the network traffic between the client and server, we usually refer to this as encrypting data in transit. Since your emails are stored in some server managed by your provider, it is also desirable that the email provider can't read their client's emails. To this end, your emails might also be encrypted when stored on the servers. This is referred to as encrypting data at rest. Cryptographic failures often end up in web apps accidentally divulging sensitive data. This is often data directly linked to customers, e.g. names, dates of birth, financial information. But it could also be more technical information such as usernames and passwords. At more complex levels, taking advantage of some cryptographic failures often involves techniques such as man-in-the-middle attacks, whereby the attacker would force user connections through a device they control. Then they would take advantage of weak encryption on any transmitted data to access the intercepted information, if the data is even encrypted in the first place. Of course, many examples are much simpler, and vulnerabilities can be found in web apps that can be exploited without advanced networking knowledge. Indeed, in some cases, the sensitive data can be found directly on the web server itself. The web application in this box contains one such vulnerability. To continue, read through the supporting material in the following tasks. Answer the questions below. Read the introduction to cryptographic failures and deploy the machine. Complete. Task 6, cryptographic failure, supporting material 1. The most common way to store a large amount of data in a format easily accessible from many locations is in a database. This is perfect for something like a web application, as many users may interact with the website at any time. Database engines usually follow the structured query language SQL syntax. In a production environment, it is common to see databases set up on dedicated servers running a database service such as MySQL or MariaDB. However, databases can also be stored as files. These are referred to as flat file databases, as they are stored as a single file on the computer. This is much easier than setting up an entire database server and could potentially be seen in smaller web applications. Accessing a database server is out with the scope of today's task, so let's focus instead on flat file databases. As mentioned previously, flat file databases are stored as a file on the disk of a computer. Usually, this would not be a problem for a web app, but what happens if the database is stored underneath the root directory of the website, i.e., one of the files accessible to the user connecting to the website? Well, we can download and query it on our own machine with full access to everything in the database. Let's see, where was I? Oh, sensitive data exposure indeed. This is a big hint for the challenge, so let's briefly cover some of the syntax we would use to query a flat file database. The most common and simplest format of a flat file database is a SQLite database. These can be interacted with in most programming languages and have a dedicated client for querying them on the command line. This client is called SQLite 3 and is installed on many Linux distributions by default. Let's suppose we have successfully managed to download a database. So if we scroll down, we can see that we have the example.db database by listing the files in the current directory. And then if we run the file command against the example.db database, we can see this is a SQLite 3.x database, written using SQLite version 303.9002, and a little bit more information. We can see that there is a SQLite database in the current folder. To access it, we use SQLite 3 database-name. Yep, right here. From here, we can see the tables in the database by using the .tables command. SQLite 3 example.db and then .tables that lists the tables, and we have one table and it's called customers. At this point, we can dump all the data from the table, but we won't necessarily know what each column means unless we look at the table information. First, let's use pragma table_info, open parentheses customers, close parentheses, semicolon to see the table information. Then we'll use select space star from customers, semicolon, to dump the information from the table. So we run pragma table_info, open parentheses customers, close parentheses, semicolon, and we get the columns for the table. So we have customer ID, which is an integer, we have customer name, which is text, credit card, which is text, and password, which is text. So then if we do select star from customers, the table, then we can get all of the data in each column. So we have the different we have customer IDs in the first column, and then in the second column we have the customer name. In the third column we have credit card numbers, and then in the fourth column we have password hashes. Okay, interesting. Hey, welcome, Iravenza. Thanks for joining. Good to see you again. We can see table information. We can see from the table information that there are 4 columns, okay? You may notice that this machine matches up with the results. Take the first row. Okay, and the next task will look at cracking this hash. Read and understand the supporting material in SQLite databases. Complete. Let's see. Task 7, cryptographic failure, supporting material 2. We saw how to query a SQLite database for sensitive data in the previous task. Topic is SQL injections? No, so I'm doing the OWASP Top 10 2021 REM on TryHackMe. So I'm running through all of the top 10 vulnerabilities, the 10 most critical web security risks. I already did broken access control, so we were looking at the ID parameter, and when we changed the ID parameter, we dropped into a different account of a different user and got the flag, and it turned out to be that if we changed the ID to 0, then we got the flag for that. And now we're looking at cryptographic failures. So basically, this does have to do with SQLite. We're looking at a SQLite database that we were able to pull down, and we were able to get the so if we go back here a little bit, we're basically talking about not using strong cryptographic algorithms for storing information in a database, such as passwords. And so what we're going to be doing is now that we have a list of users and password hashes, we're going to be cracking the password hashes, since they're not using a secure cryptographic algorithm, and they're weak to password cracking. Okay, so task 7, cryptographic failure, supporting material 2. We saw how to query a SQLite database for sensitive data in the previous task. We found a collection of password hashes, one for each user. In this task, we will briefly cover how to crack these. When it comes to hash cracking, Kali comes pre-installed with various tools. If you know how to use these, then feel free to do so. However, they are out with the scope of this material. Instead, we will be using the online tool CrackStation. This website is extremely good at cracking weak password hashes. For more complicated hashes, we would need more sophisticated tools. However, all of the crackable password hashes used in today's challenge are weak MD5 hashes, which CrackStation should handle very nicely. When we navigate to the website, we are met with the following interface. So we'll just go to CrackStation, just like this says to. Okay, just have some experience on some basic usage on how to use PostgreSQL timescale DB yet. Basic how to use. Oh, okay. So here's the interface for crackstation.net. It's a free password hash cracker. It uses a massive pre-computed lookup tables to crack password hashes. These tables store a mapping between the hash of a password and the correct password for that hash. The hash values are indexed so that it is possible to quickly search the database for a given hash. If the hash is present in the database, the password can be recovered in a fraction of a second. This only works for unsalted hashes. For information on password hashing systems that are not vulnerable to pre-computed lookup tables, see our hashing security page. I remember we did some SQL injection and some cybersecurity module back then, but I don't know what that was. On this channel? I don't remember doing any SQL injection. Maybe we did? I don't know. Or was that on a module that you did on your own? Oh, at your university. Gotcha. Okay. So let's try passing the password hash for Joy Paulson, which we found in the previous task. We solve the CAPTCHA, then click the crack hashes button. I did like 3 university modules in cybersecurity. Oh, okay, nice. So if we copy this hash, we're gonna see that this results in password. And we do the CAPTCHA, crack the hash. Yep, and we see that the result is password. We see that the hash was successfully broken and the user's password was password. How secure! It's worth noting that CrackStation works using a massive word list. If the password is not in the word list, then CrackStation will not be able to break the hash. The challenge is guided, so if CrackStation fails to break a hash in today's box, you can assume that the hash has been specifically designed not to be crackable. Read the supporting material about cracking hashes. Okay. And now onto the challenge. Man, this is going all over the place. Huh? Okay. It's now time to put what you've learned into practice. For this challenge, connect to the web application at http://IP:81. Okay. So we go over to port 81. Oh, actually, you did an internship module too? Nice. Okay. Have a look around the web app. The developer has left themselves a note indicating that there is sensitive data in a specific directory. What is the name of the mentioned directory? Good question. Let's see. What does this say? Welcome to Sense and Sensitivity. Maybe this will take us to that directory. Oh no, okay, that will just send an email. Let's read a little bit here. You reach the future world number 1 in all things therapeutic. We are a startup organization based in Taupo, New Zealand. Our location near the stunning Lake Taupo lends itself perfectly to our ideology. All mental maladies are curable. You just need to know how. We draw a great deal of inspiration from the genius of Jane Austen, whose great works serves as a beacon from a simpler time. Whilst we are currently still in our beta phase, our aim is ultimately to work with people who are struggling, to learn with them as we work together to combat the dangers of poor mental health. We aim to provide a safe and peaceful environment for those who need it. For the time being, we are only accepting beta testers of the program, so please contact us here if you feel like a stay with us amongst some of the most beautiful scenery in the world would be beneficial to you. But actually what I learned was basic stuff on how ciphers work and then some practical attacks. One module was theoretical about side channel attacks like Spectre and Meltdown. Nice. Guess I missed most of the important stuff. No, that seems pretty good. Let's see. So let's look at the page source to see if that divulges anything right away. Nope. That looks pretty clean. I don't see any comments, egregious comments or anything pointing out, or in there. Let's see. We do have a login page. We'll look at the source for that, see if there's any comment here. Oh, must remember to do something better with the database than store it in assets. There we go. So that's probably going to be what we want. Oh, and we have webapp.db, so we have a web app database right here. What is the name of the mentioned directory? That's going to be assets. Navigate to the directory you found in question 1. What file stands out as being likely to contain sensitive data? That's going to be webapp.db. Use the supporting material to access the sensitive data. What is the password hash of the admin user? Okay, so we'll go ahead and grab the database. Should be able to just download it from here. Let's create a new folder. Call this OWASP Top 10 2021. And we'll just save that right in there. Oh, just regular computer science student and masters, not cybersecurity as main. That's pretty awesome though. You must be decent at programming then. Okay. So let's take a look at this database. Let's call this tab VPN. Open a new tab. And call this cd into documents. TryHackMe. Top 10 2021. Light free web app tables. Select star from users. Okay, and oh, we don't know. Whoops, we don't know what columns we have though. We want to know what the columns are. I forget what that was. Oh yeah, pragma table underscore info. Pragma table underscore info users. Okay, so we've got user ID. So this is the user ID of the admin user. User ID for Bob, user ID for Alice. And then in the second column, we have the username. And then in the third column, we have the password. And admin actually seems to be its own column as well. Okay, so this is a password hash for the admin user. Oh, okay, so the fourth column is admin, and then there's an integer, and if it's a 1, then that means they're an admin. If there's a 0, then that means they're not an admin. So the users admin and Bob are both admins. Okay, interesting. So we have this. Okay, password hash of the admin user. Submit that. And then we'll crack the hash. What is the admin's plain text password? So we're just gonna use crack station again. And do the captcha and crack the hash. And their password is QWERTY UIOP. Login as the admin. What is the flag? Okay. So let's go back into login.php. Admin. And their password. Login. And there's the flag. Oops. That. Hey, now Iravinza, we're gonna be moving on to injection, so there will probably be some SQL injection here. Yep, we're gonna be going over SQL injection. Oh dang, every time that we find a password, we should play the little, password video clip. I always forget about that.
Password warning.
Alright!
Basic principle, you put a semicolon between commands. Yeah, you can do command chaining that way. Okay, injection. Injection flaws are very common in applications today. These flaws occur because the application interprets user-controlled input as commands or parameters. Injection attacks depend on what technologies are used and how these technologies interpret the input. Some common examples include SQL injection. This occurs when user-controlled input is passed to SQL queries. As a result, an attacker can pass in SQL queries to manipulate the outcome of such queries. This could potentially allow the attacker to access, modify, and delete information in a database when this input is passed into database queries. This would mean an attacker could steal sensitive information such as personal details and credentials. And then we have command injection. This occurs when user input is passed to system commands. As a result, an attacker can execute arbitrary system commands on application servers, potentially allowing them to access users' systems. The main defense for preventing injection attacks is ensuring that user-controlled input is not interpreted as queries or commands. There are different ways of doing this. Using an allow list, when input is sent to the server, this input is compared to a list of safe inputs or characters. If the input is marked as safe, then it is processed. Otherwise, it is rejected and the application throws an error. Stripping input. If the input contains dangerous characters, these are removed before processing. Dangerous characters or input is classified as any input that can change how the underlying data is processed. Instead of manually constructing allow lists or stripping input, various libraries exist that can perform these actions for you. I've understood injection attacks. Complete. Sometimes input gives you a predefined pre-input, like select user input from. So you could do, like in a general speak, select star from all, select star from, whatever input would be inserted here by the backend. Yep, we actually did that with the web app database here. So we did select star from the users tables. Or the users table, and we're able to list all the information in that table, all of the columns. Okay, so command injection. Whoops, let's add an hour to the box. Command injection. Command injection occurs when server-side code like PHP in a web application makes a call to a function that interacts with the server's console directly. An injection web vulnerability allows an attacker to take advantage of that call to execute operating system commands arbitrarily on the server. The possibilities for the attacker from here are endless. They could list files, read their contents, run some basic commands to do some recon on the server, or whatever they wanted, just as if they were sitting in front of the server and issuing commands directly onto the command line. Once the attacker has a foothold on the web server, they can start the usual enumeration of your systems and look for ways to pivot around. Hey, welcome from YouTube, Movie Tula. How are you doing? Explain again what command injection is. We're looking at the OS Top 10, the Open Web Application Security Project, the 2021 version, and we're looking at injection web app vulnerabilities right now, and we're looking at command injection specifically. Command injection happens when server-side code in a web application makes a call to a function that interacts with the server's console directly. This allows an attacker to take advantage of that call to execute operating system commands arbitrarily on the server. With this, the possibilities are endless. You can list files, read contents, run some basic commands to do recon on the server, or basically whatever the system interprets as a command you can do with the permissions under the user that the web application is running as. And once an attacker has a foothold on the web server, they can start the usual enumeration and look for ways to pivot around. So, like pivoting from an external network like the internet, finding a command injection vulnerability in the web app itself, and then using that to gain like a remote code execution and get a reverse shell on the machine, and then do some enumeration to find out if they can then pivot onto the internal network to other various machines on the internal network. Awesome. Okay, so we have a little code example here now. Let's consider a scenario. MooCorp has started developing a web-based application for cow ASCII art with customizable text. While searching for ways to implement their app, they've come across the cowsay command in Linux, which does just that. Instead of coding a whole web application and the logic required to make cows talk in ASCII, they decide to write some simple code that calls the cowsay command from the operating system's console and sends back its contents to the website. Pog cowsay? Let's look at the code they use for their app. See if you can determine why their implementation is vulnerable to command injection. We'll go over it below. So we have a open PHP tag. If is set $_get mooing. $mooing equals $_get. Mooing $cow equals default. If is set $_get cow. $cow equals $_get cow. Pass through Perl user bin cowsay. Tag F $cow mooing. Close PHP tag. In simplest terms, the above snippet does the following. Checking if the parameter mooing is set. Okay. If it is, the variable $mooing gets what was passed into the input field. Okay. Checking if the parameter cow is set. Okay. If it is, the variable $cow gets what was passed through the parameter. What if user says, so cowsay is over? Sorry, what do you mean by that, Ruvenza? Let's see. The program then executes the function pass through Perl user bin cowsay tech F $cow $mooing. The pass-through function simply executes a command in the operating system's console and sends the output back to the user's browser. You can see that our command is formed by concatenating the $cow and $mooing variables at the end of it. Since we can manipulate those variables, we can try injecting additional commands by using simple tricks. If you want to, you can read the docs on pass-through on PHP's website for more information on the function itself. So if we do TryHackMe, and we choose our cow default, so we've got Perl user bin cowsay tech F default TryHackMe. So then that prints some ASCII art to the screen saying TryHackMe. Exploiting command injection. Looking at Linux shell, if you pass something so it includes like cowsay meow, some shellcode, as far as I understand the description, but that semicolon must somehow be encoded. Exploiting command injection. Now that we know how the application works behind the curtains, we will take advantage of a bash feature called inline commands to abuse the cowsay server and execute any arbitrary command we want. Bash allows you to run commands within commands. This is useful for many reasons, but in our case, it will be used to inject a command within the cowsay server to get it executed. To execute inline commands, you only need to enclose them in the following format. $, open parentheses, your underscore command underscore here, close parentheses. If the console detects an inline command, it will execute it first and then use the result as the parameter for the outer command. Look at the following example, which runs who am I as an inline command inside an echo command. So then we have echo open double quote, my username is $, open parentheses, who am I, close parentheses, close double quote, my username is djoe. Parse the result back in the outer command, execute echo. So coming back to the cowsay server, here's what would happen if we send an inline command to the web application. $, who am I? Default Apache. So that tells us who the user of the that the web application is running as. Since the application accepts any input from us, we can inject an inline command which will get executed and used as a parameter for cow say. This will make our cow say whatever the command returns. In case you are not familiar with Linux, here are some other commands you may want to try. whoamid ipconfig /ipaddr rename-a ps-ef. To complete the questions below, navigate to http:// IP:82 and exploit the cowsay server. What strange text files in the website's root directory? Nice. Okay, so we go over to port 82 for the web server now. $, who am I? Apache. What strange text file is in the website's root directory? Okay, so ls-la. Guess we don't have to do LA. They have different ones too. Yeah, we can't print that. Oh, here we go. drpepper.text. How many non-root, non-service, non-daemon users are there? Okay. Let's see. We may need to dash away, grep. Has been no login. Nope. Now, normally, as far as I know, you can usually run tree on a Windows system, but this is a Linux system. I'm not sure if... I've never used tree on Linux before. Shit, how do I get out of here? There we go. Let's see, tree... Okay, so yeah, we do have the tree command. On here, not on this, Linux system that we're working with, though. Okay. Tree exists on Linux. It's a common benchmarking tool to show terminal performance. Yeah, it just doesn't seem to be installed on here. Okay, how many non-root, non-service, non-daemon users are there? Can we do... let's see. Yep.
Hell yeah! Coming live!
Numplex followed your channel.
Hey, thank you for the follow, Numplex. Appreciate it. Welcome. Okay. Login. Can we do that? No. Let's see. Here we go. How many non-root, non-service, non-daemon users are there? Oh, no, I guess we... Let's see. No. Let's see. Ben Ash, interesting. Is root the only one? Yeah. So that's not gonna be it.
Do you remember?
Let's see. Think free BSD uses Ash by default, or that was CSH, one of the two. We could probably figure that out pretty quickly if we did. Well, actually, we could do uname tac A.
Do you remember?
This is an Ubuntu machine, it looks like. Yeah. Let's see, OS release. Oh, this is Alpine Linux. Okay, interesting. Let's see, password. How many non-root, non-service, non-daemon users are there? And it's a single digit. You always use bash. So in Kali Linux, which is what I'm running on my virtual machine here, it uses
Do you remember?
whoops. I forget what the
Just us and our dreams.
dollar sign. No.
Do you remember? I do.
Oh, shell. Crap. So, by default, Kali Linux uses Z shell. So that's what I'm running for my shell here. Gosh dang it, how do we figure this out? Is it 9?
I remember.
No. How many non-root, non-service, non-daemon users are there?
Maybe you should leave.
Forget how to grep for that.
I remember. We were so happy then. We were different.
How to...
Weren't we?
Yep, pretty much.
I remember.
How to grep
Do you?
for... Whoops. Not that. Yeah.
I remember.
Sorry, there's a fly buzzing around here. Let's see. This one always stumps me. I've done this this room before a couple times. Well, one time I think. And there's a way to grep for this, but I forget exactly how to do that. We could use awk. We can just grep for this somehow, though. Forget how, though. Considering that all users with ID greater than or equal to 1000 are non-system users, how can we get a list of users in a single command? Let's try this awk command. Oh, so the question we're trying to answer is how many non-root, non-service, non-daemon users are there? And that didn't work. There's more than one. These have to be all service accounts, probably. Because there are way too many here. We're looking for a single digit, so anywhere in between 0 and 9. Is it 0? It's probably not 0. Oh, it is 0. Okay. Okay, what user is this app running as? We saw earlier that that is Apache. What is the user's shell set as? So all we have to do is do cat etc password rep Apache. Sbin no login. What version of Alpine Linux is running? We saw that earlier. LS. No. Yes. Cat. Let's see. OS-release. 3.16.0. Moving on to insecure design now. Alpine, I do even have at least some plan of it. Oh, yeah. I usually use that as container based because it uses OpenRC. Ah, yeah. Not sure why they decided to go with Alpine Linux. Okay. Insecure design. Insecure design refers to vulnerabilities which are inherent to the application's architecture. They are not vulnerabilities regarding bad implementations or configurations, but the idea behind the whole application or part of it is flawed from the start. Most of the time, these vulnerabilities occur when an improper threat modeling is made during the planning phases of the application and propagate all the way up to your final app. Some other times, insecure design vulnerabilities may also be introduced by developers while adding some shortcuts around the code to make their testing easier. A developer could, for example, disable the OTP validation in the development phases to quickly test the rest of the app without manually inputting a code at each login, but forget to re-enable it when sending the application to production. I think they want it minimalistic and secure, so they use a non-common libc and non-common init system. Let's say they weren't affected by the XZ vulnerability. Insecure password resets. A good example of such vulnerabilities occurred on Instagram a while ago. Instagram allowed users to reset their forgotten passwords by sending them a 6-digit code to their mobile number via SMS for validation. If an attacker wanted to access a victim's account, he could try to brute force the 6-digit code. As expected, this was not directly possible as Instagram had rate limiting implemented so that after 250 attempts, the user would be blocked from trying further. One 150 is quite a large number. Let's see. However, it was found that the rate limiting only applied to code attempts made from the same IP. If an attacker had several different IP addresses from where to send requests, he could now try 250 codes per IP. For a 6-digit code, you have 1 million possible codes, so an attacker would need 1 million divided by 250, which equals 4,000 IPs, to cover all possible codes. This may sound like an insane amount of IPs to have, but cloud services make it easy to get them at a relatively small cost, making this attack feasible. So now, if we have 4,000 IPs, that greatly decreases the amount of work that we have to do in order to guess the 6-digit code. Okay, so we have a little example here. We have computer 1, computer 2, and computer N. For some reason, why they decided to go with N, I'm not sure. Computer 1 does 0000000 through 000249. The next computer does 000250 through 00499. And then we've got 999751 through 999. Notice how the vulnerabilities are related to the idea that no user would be capable of using thousands of IP addresses to make concurrent requests to try and brute force a numeric code. The problem is in the design rather than the implementation of the application in itself. Since insecure design vulnerabilities are introduced at such an early stage in the development process, resolving them often requires rebuilding the vulnerable part of the application from the ground up, and is usually harder to do than any other simple code-related vulnerability. The best approach to avoid such vulnerabilities is to perform threat modeling at the early stages of the development lifecycle. To get more information on how to implement secure development lifecycles, be sure to check out the SSDLC room. Practical example. Navigate to the website on port 85 and get into Joseph's account. This application also has a design flaw in its password reset mechanism. Can you figure out the weakness in the proposed design and how to abuse it? Try to reset Joseph's password. Keep in mind the method used by the site to validate if you are indeed Joseph. What is the value of the flag in Joseph's account? Okay, so now I'll go to port 85 of the web application. I forgot my password. Username. We're looking at Joseph. Why they decided to make the username obfuscated, I don't know, but anyway, let's move on. What is your mother, sister's, son's, nephew's, neighbor's, friend name? Yeah, we're not gonna use that one. Ooh, what is your favorite color? Maybe we can guess his favorite color. What's your first pet's current address? Let's do favorite color, because that's gonna be the easiest to guess. My favorite color is green, so let's try green. Oh, success. The password for user Joseph has been reset to this password. Well, that was easy. His favorite color is green too, apparently. Username actually is the password. Okay. So now we'll log in as him. And hope that we copied the password. Oh, that's interesting. When you actually try to go log in, though, username is in plain text. That's interesting. Okay, so let's log in. Then we'll open up notes.txt. And hopefully... Oh, remember to move private files out of the server. Okay, so the flag isn't in there. Private... maybe? Oh, there's the flag. THM, not even cats could save you. Huh. Okay. Submit that. We'll add another hour onto the machine. Okay. Task 12. The fifth OWASP web application vulnerability. Security misconfiguration. We got another password, guys. We need to keep up with the little password clip every time we find a valid password.
All right.
Okay. Security misconfiguration. Security misconfigurations are distinct from the other top 10 vulnerabilities because they occur when security could have been appropriately configured but was not. Even if you download the latest up-to-date software, poor configurations could make your installation vulnerable. Security misconfigurations include poorly configured permissions on cloud services like S3 buckets, having unnecessary features enabled like services, pages, accounts, or privileges, default accounts with unchanged passwords, error messages that are overly detailed and allow attackers to find out more about the system, not using HTTP security headers. Oh, yes. Werkzeug, yeah. Where did you see? Oh, down a little bit. Okay. Did I pronounce that right? Werkzeug? Okay. Awesome. Uh-huh. Let's see. This vulnerability can often lead to more vulnerabilities. Oh, a bit too sharp? Okay. Werkzeug? Is that better? Okay. For more info, look at the OWASP Top 10 entry for security misconfiguration. Oh, I skipped a line. This vulnerability can often lead to more vulnerabilities, such as default credentials, giving you access to sensitive data, XML external entities, XXE, or command injection on admin pages. Debugging interfaces. Oh, that's a lot better. Thank you very much, Ravenza. Vielen Dank. Actually, Germans do not have that sharp language they are known for, and what you last said was like accent-free. Ah, thank you very much. I really appreciate that. Debugging interfaces. A common security misconfiguration concerns the exposure of debugging features in production software. Debugging features are often available in programming frameworks to allow the developers to access advanced functionality that is useful for debugging an application while it's being developed. Attackers could abuse some of those debug functionalities if somehow the developers forgot to disable them before publishing their applications. One example of such vulnerability was allegedly used when Patreon got hacked in 2015. 5 days before Patreon was hacked, a security researcher reported to Patreon that he had found an open debug interface for a Werkzeug console. Werkzeug is a vital component in Python-based web applications as it provides an interface for web servers to execute the Python code. Werkzeug includes a debug console that can be accessed either via URL on /console, or it will also be presented to the user if an exception is raised by the application. In both cases, the console provides a Python console that will run any code you send to it. For an attacker, this means he can execute commands arbitrarily. Oh dear. Hey, welcome, DJ. Good to have you. Thanks for joining. So we're just going over the OWASP Top 10 2021 version. Wouldn't running a web server on a different port than 443 or 80 increase security as the person connecting would need to know the port? Yeah, it could. If we could run Nmap against it and find out what port it was running on, though, then that might defeat the purpose of that. And we can scan all 65,535 ports. So it would take a little bit of enumeration. We wouldn't maybe think to check like a high port right away, but we could definitely ascertain what port the web server might be running on with a Nmap scan, scanning all 65,535 ports. Okay. So we have a interactive console here on /console of the Werkzeug debugging console. So let's look at a practical example. Do you think 3048-bit keys are needed as of right now, or do you think 2048-bit is still good? I don't know much about, like, cracking those types of cryptographic keys, so I'm not exactly sure what is considered to be, like, really difficult to crack. I would imagine that it takes a pretty decent amount of time to crack a 2048-bit key, though. 2048 should be fine, as Git also recommends using a 2048 Git key. Yeah, so it's probably pretty good. It would probably take quite a bit of time and quite a few resources to crack that that cryptographic key. Okay, practical example. This VM showcases a security misconfiguration as part of the OWASP Top 10 vulnerabilities list. Navigate to the website on port 86 and try to exploit the security misconfiguration to read the application source code. Okay, we're gonna go over to port 86 now. We'll take a look at the source code. Nothing too interesting. We'll go over to the Werkzeug console, /console. Navigate to the website on port 86 /console to access the Werkzeug console. In their tutorial how to set up a secure key, supercomputers could someday defeat the RSA algorithm altogether. People would need to migrate to ECDSA. I guess if 2048 keys are cracked, the 4096 ones are just a minute apart on these computers. Yeah, brute force attacks on SSL, bro. It is scary when you think about it. Yeah, it takes a decent amount of time and resources, though. So it would take a very well-funded attacker to try to break those keys, most likely. Use the Werkzeug console to run the following Python code to execute the ls-l command on the server. Okay, so let us copy this. Error. Oh, whoops, did I not copy the complete? No, I forgot the I on import. Okay. What is the database file name, the one with the .db extension in the current directory? That is to-do.db. Okay. Modify the code to read the contents of the app.py file, which contains the application's source code. What is the value of the secret _ flag variable in the source code? Okay. So we'll just change this to I guess. Oops, we'll have to make sure I have an I there. Secret _ flag. There it is. Submit that. Okay, perfect. Okay, number 6, vulnerable and outdated components. Occasionally, you may find that the company, entity you're pen testing is using a program with a well-known vulnerability. For example, let's say that a company hasn't updated their version of WordPress for a few years. And using a tool such as WP-Scan, you can find that it's version 4.6. Some quick research will reveal that WordPress 4.6 is vulnerable to an unauthenticated remote code execution (RCE) exploit. And even better, you can find an exploit already made on ExploitDB. As you can see, this would be quite devastating because it requires very little work on the attacker's part. Since the vulnerability is already well known, someone else has likely made an exploit for the vulnerability already. The situation worsens when you realize that it's really easy for this to happen. If a company misses a single update for a program they use, it could be vulnerable to any number of attacks. Read about the vulnerability. Okay, complete. How much more? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We might not get through all of these tasks today, but we'll just pick up on Thursday from here if we don't finish today. Vulnerable and outdated components. Exploit. Recall that since this is about known vulnerabilities, most of the work has already been done for us. Our main job is to find out the information of the software and research it until we can find an exploit. Let's go through that with an example web application. Nostromo 1.9.6. What do you know? This server has the default page for the Nostromo web server. Now that we have a version number and a software name, we can use exploitdb to try and find an exploit for this particular version. And there we go, Nostromo 1.9.6, remote code execution. Lucky us, the top result happens to be an exploit script. Let's download it and try to get code execution. Running this script on its own teaches us a very important lesson. Exploits you download from the internet may not work the first time. It helps to understand the programming language the script is in so that, if needed, you can fix any bugs or make any modifications, as quite a few scripts on exploitdb expect you to make modifications. Fortunately, the error was caused by a line that should have been commented out, so it's an easy fix. But I'm not sure if that really helps anymore. One like a supercomputer with enough strengths as you asked for. It wouldn't, yeah. Let's see. Fortunately, the error was caused by a line that should have been commented out, so it's an easy fix. So this line needs to be commented. Fixing that, let's try and run the program again. Python 2, the Python script, and then in this case localhost, port 80, ID. And we find out that the ID of the user that the application is currently running as is 1001. Okay, let's see. Boom! We have RCE. Now it's important to note that most scripts will tell you what arguments you need to provide. Exploit developers will rarely make you read potentially hundreds of lines of code just to figure out how to use the script. It is also worth noting that it may not always be this easy. Sometimes you will just be given a version number, like in this case, but other times you may need to dig through the HTML source or even take a lucky guess on an exploit script. But realistically, if it is a known vulnerability, there's probably a way to discover what version the application is running. That's really it. The great thing about this piece of the OWASP Top 10 is that the work is already done for us. We just need to do some basic research, and as a penetration tester, you're already doing that quite a bit. Read the above. Okay, complete that. Let's move on to task 15, vulnerable and outdated components, lab. Okay, so we'll navigate to the website on port 84, where we'll find a vulnerable application. All the information you need to exploit it can be found online. Okay. So we'll go over here to port 84. Welcome to Online CSE Bookstore. This site has been made using PHP with MySQL procedure functions. The layout used Bootstrap to make it more responsive. It's just a simple web. So let's go to exploit DB. We'll search for CSE Bookstore. Admin login. Search CSE Bookstore. Multiple SQL injection, persistent cross-site scripting, authentication bypass. What is the content of the opt_flag.txt file? You know it's a bookstore application. You should check for recent unauthenticated bookstore apps, RCEs. Yeah, none of these are RCE. This is SQL injection. We have persistent cross-site scripting, authentication bypass. Let's just search for bookstore, maybe. No? I'm not finding a RCE exploit. Privilege escalation remote database download. Ah, here we go. Okay, so download the exploit. It's a Python script. I'm gonna rename it to exploit.py. Save that. Okay. So let's see. This might be Python 2. Oops. Exploit.py. See if there's any help. Okay, so we just need the URL of the target, it looks like. Okay, and it does seem to be, well, we can try Python 2, 3. Yeah, it looks like it works either way. Sweet. Okay. Okay, so we just need to pass in the URL. Hopefully, nope, no shell. Yes, I would like a shell, thank you. Sweet. Okay, we have remote code execution on the web server now. And now we want to find out what the contents of opt_flag.txt are. Flag.txt. There we go. THM, but it's not my fault. Huh. I mean, it is a little bit your fault. Submit. Okay. Okay, task 16. Identification and authentication failures. Authentication and session management constitute core Components of modern web applications. Authentication allows users to gain access to web applications by verifying their identities. Most common form of authentication is using a username and password mechanism. A user would enter these credentials and the server would verify them. The server would then provide the user's browser with a session cookie if they are correct. A session cookie is needed because web servers use HTTPS to communicate, which is stateless. Attaching session cookies means the server will know who is sending what data. The server can then keep track of users' actions. Let's see. If an attacker is able to find flaws in an authentication mechanism, they might successfully gain access to other users' accounts. This would allow the attacker to access sensitive data depending on the purpose of the application. Some common flaws in authentication mechanisms. Include the following: brute force attacks. If a web application uses usernames and passwords, an attacker can try to launch brute force attacks that allow them to guess the username and passwords, using multiple authentication attempts. Use of weak credentials. Web applications should set strong password policies. If applications allow users to set passwords such as password 1 or common passwords, an attacker can easily guess them and access user accounts. Weak session cookies. Session cookies are how the server keeps track of users. If session cookies contain predictable values, attackers can set their own session cookies and access users' accounts. There can be various mitigations for broken authentication mechanisms depending on the exact flaw. To avoid password guessing attacks, ensure the application enforces a strong password policy. To avoid brute force attacks, ensure that the application forces an automatic lockout after a certain number of attempts. This would prevent an attacker from launching more brute force attacks. Implement multi-factor authentication. If a user has multiple authentication methods, for example, using a username and password and receiving a code on their mobile device, it would be difficult for an attacker to get both the password and the code to access the account. I've understood broken authentication mechanisms. Complete. Identification and authentication failures practical. For this example, we'll look at a logic flaw within the authentication mechanism. Many times what happens is that developers forget to sanitize the input, username and password, given by the user in the code of their application, which can make them vulnerable to attacks like SQL injection. However, we will focus on a vulnerability that happens because of a developer's mistake, but is very easy to exploit, i.e., re-registration of an existing user. Let's understand this with the help of an example. Say there is an existing user with the name admin, and we want access to their account. So what we can do is try to re-register that username, but with slight modification. We will enter space admin without the quotes. Notice the space at the start. Now when you enter that in the username field and enter other required information like email ID or password and submit that data, it will register a new user. But that user will have the same right as the admin account. That new user will also be able to see all the content presented under the user admin. To see this in action, go to the excuse me. Go to the web application on port 8088. Okay. Learn about attacking authentication. This room will focus on teaching on basics of attacking the authentication systems. Okay. And try to register with Darren as your username. You'll see that the user already exists, so try to register space Darren instead, and you'll see that you are now logged in and can see the content present only in Darren's account, which in our case is the flag that you need to retrieve. Okay? So, register. Username Darren. Darren at THM. And then password. We'll do hacks of go. Register. Save. Error, this user is already registered. Okay, so now we'll try to register the same user with a space. Darren at thm.com. Password hacks of go. Register. User registered successfully. Now let's log in as them. Darren. Space Darren. And we're logged in as Darren. Okay, so we'll copy the flag. Now try to do the same trick and see if you can log in as Arthur, okay? So we'll log out as Darren. Register. Arthur. Space Arthur. Arthur at HM.com. Password hacks Hobgoblin. Register. User registered successfully. Space Arthur. Password hacks Hobgoblin. I probably messed that up. Yes. Okay. Arthur. Password hacks Hobgoblin. Gosh dang it. Okay, awesome. Got his flag. Sweet. Okay, so that's done. Hey, Iruvinza, I don't know if you've seen me before, but I'll use that Python 3 web server a lot when I do like CTFs and stuff, so that I can set up files on a quick web server so that I can download those onto the from the box that I've compromised. Let's see. Okay, number 8. Software and data integrity failures. What is integrity? When talking about excuse me. Okay. No worries. When talking about integrity, we refer to the capacity we have to ascertain that a piece of data remains unmodified. Integrity is essential in cybersecurity as we care about maintaining important data free from unwanted or malicious modifications. For example, say you are downloading the latest installer for an application. How can you be sure that while downloading it, it wasn't modified in transit or somehow got damaged by a transmission error? To overcome this problem, you will often see a hash sent alongside the file so that you can prove that the file you downloaded kept its integrity and wasn't modified in transit. A hash or digest is simply a number that results from applying a specific algorithm over a piece of data. When reading about hashing algorithms, you'll often read about MD5, SHA-1, SHA-256, or many others available. Let's take WinSCP as an example to understand better how we can use hashes to check a file's integrity. If you go to their SourceForge repository, you'll see that for each file available to download, there are some hashes published along. So we can see that here. We have WinSCP and we have the MD5, SHA-1, and 256 hashes. These hashes were pre-calculated by the creators of WinSCP so that you can check the file's integrity after downloading. If we download the WinSCP-5.21.5-setup.exe file, we can recalculate the hashes and compare them against the ones published in SourceForge. To calculate the different hashes in Linux, we can use the following commands. We can do MD5 sum and then the executable, and that will give us the MD5 sum for the executable. You can do the same with SHA-1 and SHA-256. Since we got the same hashes, we can safely conclude that the file we downloaded is an exact copy of the one on the website. Software and data integrity failures. This vulnerability arises from code or infrastructure that uses software or data without using any kind of integrity checks. Since no integrity verification is being done, an attacker might modify the software or data passed to the application, resulting in unexpected consequences. There are mainly two types of vulnerabilities in this category: software integrity failures and data integrity failures. Read the above and continue. Okay, complete. Task 19, software integrity failures. Suppose you have a website that uses third-party libraries that are stored in some external servers that are out of your control. While this may sound a bit strange...
To F then followed your channel.
Hey, thank you for the follow to Ven. Appreciate it. Welcome in. We're just going over the OWASP Top 10 2021 version, and we're looking at software integrity failures, which is the 8th web app vulnerability in the OS Top 10 2021 list. Okay, so let's see. Suppose you have a website that uses third-party libraries that are stored in some external servers that are out of your control. While this may sound a bit strange, this is actually a somewhat common practice. Take as an example jQuery, a commonly used JavaScript library. If you want, you can include jQuery in your website directly from their servers without actually downloading it by including the following line in the HTML code and download jQuery from the specified external source. Okay. Oops. Script source equals https:// code.jquery.com. /jQuery-3.6.1.min.js and script tag. When a user navigates to your website, its browser will read its HTML code and download jQuery from the specified external source. Okay? The problem is that if an attacker somehow hacks into the jQuery official repository, they could change the contents of the code to inject malicious code. As a result, anyone visiting your website would now pull the malicious code and execute it into their browsers unknowingly. This is a software integrity failure, as your website makes no checks against the third-party library to see if it has changed. Modern browsers allow you to specify a hash along the library's URL so that the library code is executed only if the hash of the downloaded file matches the expected value. This security mechanism is called Sub-Resource Integrity, SRI, and you can read more about it here at this link. The correct way to insert the library in your HTML code would be to use SRI and include an integrity hash so that if somehow an attacker is able to modify the library, any client navigating through your website won't execute the modified version. Here's how that should look in HTML. Open script tag, source equals the jQuery repository, integrity equals SHA-256 dash the SHA-256 hash, equals cross origin equals anonymous close script tag. You can go to srihash.org to generate hashes for any library if needed. Interesting. I can tell you my company is also something with jQuery. Pretty every website I debugged into had it actually. Yes, jQuery is very common. What is the SHA-256 hash of this jQuery repository? So remember, you can use srihash.org to calculate integrity hashes for SRI. So let's do that. Resource URL, and we want SHA-256. Okay, so this is the hash. Perfect. Okay. Data integrity failures. Hey guys, I gotta run to the restroom real quick, but I'll be right back. And I'm back. Okay. Data integrity failures. Let's think of how web applications maintain sessions. Usually when a user logs into an application, they will be assigned some sort of session token that will need to be saved on the browser for as long as the session lasts. This token will be repeated on each subsequent request so that the web application knows who we are. These session tokens can come in many forms, but are usually assigned via cookies. Cookies are key value pairs that a web application will store on the user's browser, and that will be automatically repeated on each request to the website that issued them. For example, if you were creating a webmail application, you could assign a cookie for each user after logging in that contains their username. In subsequent requests, your browser would always send you your username and the cookie so that your web application knows what user is connecting. This would be a terrible idea security-wise because, as we mentioned, cookies are stored on the user's browser. So if the user tampers with the cookie and changes the username, they could potentially impersonate someone else and read their emails. This application would suffer from a data integrity failure as it trusts data that an attacker can tamper with. One solution to this is to use some integrity mechanism to guarantee that the cookie hasn't been altered by the user. To avoid reinventing the wheel, we could use some token implementations that allow you to do this and deal with all of the cryptography to provide proof of integrity without you having to bother with it. One such implementation is JSON Web Tokens, JWT. JWTs are very simple tokens that allow you to store key value pairs on a token that provides integrity as part of the token. The idea is that you can generate tokens that you can give your users with the certainty that they won't be able to alter the key value pairs and pass the integrity check. The structure of a JWT token is formed of 3 parts. So we have the header, we have the payload in the middle, and we have the signature. The header contains metadata indicating this is a JWT, and the signing algorithm in use is HS256, and we can see that here. The payload contains the key value pairs with the data that the web application wants the client to store. The signature is similar to a hash. So going back to the payload, we have username is guest, and then the expiration key value pairs with the data the web application wants the client to store. So this is probably some kind of an expiration on the JSON web token. The signature is similar to a hash taken to verify the payload's integrity. If you change the payload, the web application can verify that the signature won't match the payload and know that you tampered with the JWT. Unlike a simple hash, this signature involves the use of a secret key held by the server only, which means that if you change the payload, you won't be able to generate the matching signature unless you know the secret key. Notice that each of the 3 parts of the token is simply plaintext encoded with base 64. You can use this online tool to encode decode base 64. Try decoding the header and payload of the following token. So just the payload. Oh wait, no. We want to decode the header and payload. So the header and the payload. I'm just gonna use CyberChef for this. CyberChef is kind of a Swiss Army knife of dealing with encoded and other different types of data. We can do different things with the data, like there's hashing. You can encode to base64. You can decode base64. Just a whole bunch of different things in here. There's regular expression, all kinds of different things. We're just gonna need, for this, the header. We're gonna go from base64. We might need the dot at the end. Maybe not, though. Let's see. Okay, note, the signature contains binary data, so even if you decode it, you won't be able to make much sense of it anyways. JWT and the none algorithm. A data integrity failure vulnerability was present on some libraries implementing JWTs a while ago. As we have seen, JWT implements a signature to validate the integrity of the payload data. The vulnerable libraries allowed attackers to bypass the signature validation by changing the two following things in a JWT. Modify the header section of the token so that the alg header would contain the value none, and remove the signature part. Taking the JWT from before as an example, if we wanted to change the payload so that the username becomes admin and no signature check is done, we would have to decode the header and payload, modify them as needed, and encode them back. Notice how we removed the signature part but kept the dot at the end. Okay, so they don't actually show that though. Alg is none, and then we set username to admin. So we had to decode the header first and change alg to none, and then redecode that with base64. And then we had to decode the payload and change that username to admin, and then re-encode that with base64. It sounds pretty simple. Let's walk through the process an attacker would have to follow in an example scenario. Navigate to the web app on port 8089 and follow the instructions in the questions below. Okay, so we'll go over to port 8089 of the web application. Cookies for all, username, password, login. Okay. Try logging into the application as guest. What is guest's account password? Invalid credentials. You can also log in as guest with password guest. Okay. Huh? Log in. Don't save. Hello, guest. Only the admin user is allowed to get the flag. Yes, cookies are very interesting and cool things to mess around with on web applications. Try logging into the application as guest. What is guest's account password? It's just guest. If your login was successful, you should now have a JWT stored as a cookie in your browser. Press F12 to bring out the developer tools. Depending on your browser, you will be able to edit cookies from the following tabs. Okay, let's bring this over here. Storage. Okay, so we have our JWT session cookie right here. We also have a PHP session ID. Let's see. What is the name of the website's cookie containing a JWT token? That would be JWT-session. Use the knowledge gained in this task to modify the JWT token so that the application thinks you are the user admin. What is the flag presented to the admin user? Okay, so let's do that. We're gonna grab just the header. Actually, we're probably gonna have to... Let's see, how do we copy this? Okay, so we want the header first. And we'll go back over to CyberChef and put this here. Take this, copy, and delete the recipe. And we need to change this to none. And then we need to re-encode this with base64. And that doesn't look like that worked for some reason. Is this... let's see. No, it is TYP. Oh, there we go. Okay. So we'll copy that. Oops. Paste that here. Period. And then we'll take the payload. And decode it. And then we'll copy this and clear the recipe, clear this, paste this in here, and then we change guest to admin, and then we need to re-encode this with base64, and there we go. Copy that to clipboard. And put that there. And then we'll take
Hell yeah!
the last part.
Sufyan_Hakam followed your channel.
Hey, thank you for the follow, Sufyan_Hakam. Appreciate it. Welcome. Thanks for joining. Let's see if this worked. Okay. So now we should be able to replace this with our value. And become the admin user. Either the token or its signature is invalid, no flag for you. Oh, crap. Okay, so let's try this again. Maybe it includes the dot. Oops. Okay, so we'll copy this. We did change alg to none, right? Yes, okay. So that's right. So I change this to none. Let me go to base We're just changing the header and the payload. The dot be included? I don't think the dot is included. Change this to none. We go to base 64. Copy this. Let me take the payload. Paste this in here. And we should be able to just change this to admin and go to base 64. Whoops. Copy that. And then do that. Valid token is missing. It's interesting. completely gotten rid of the token for some reason. Either the token or its signature is invalid, no flag for you. What the hell? Okay, let's look at how I did this up here. Oh, remove the signature part? Oh, okay. That's the problem. So that's supposed to be completely removed. What? Create session. So the correct value should be this. And refresh. There we go. Awesome. THM, don't take cookies from strangers, is the flag. Okay, paste that there. Complete. Just about done. Let's add an hour onto our machine. Hey, Louis, welcome from YouTube. Thanks for joining. Or Lucy, I'm sorry. Lucy. I misread your username. How are you doing? Glad to have you. Let's see. Okay, so number 9 of the OWASP Top 10 version 2021. Security logging and monitoring failures. When web applications are set up, every action performed by the user should be logged. Logging is important because, in the event of an incident, the attacker's activities can be traced. Once their actions are traced, their risk and impact can be determined. Without logging, there would be no way to tell what actions were performed by an attacker if they gain access to particular web applications. The more significant impacts of these include Regulatory damage. If an attacker has gained access to personally identifiable user information, and there is no record of this, final users are affected, and the application owners may be subject to fines or more severe actions depending on regulations. Risk of further attacks. An attacker's presence may be undetected without logging. This could allow an attacker to launch further attacks against web application owners by stealing credentials, attacking infrastructure, and more. The information stored in logs should include the following: HTTP status codes, timestamps, usernames, API endpoints, page locations, and IP addresses. These logs have some sensitive information, so it's important to ensure that they are stored securely and that multiple copies of these logs are stored at different locations. As you may have noticed, logging is more important after a breach or incident has occurred. The ideal case is to have monitoring in place to detect any suspicious activity. The aim of detecting this suspicious activity is to either stop the attacker completely or reduce the impact they've made if their presence has been detected and much later than anticipated. Common examples of suspicious activity include multiple unauthorized attempts for a particular action, usually authentication attempts or access to unauthorized resources, e.g. admin pages. Requests from anomalous IP addresses. Or locations. While this can indicate that someone else is trying to access a particular user's account, it can also have a false positive rate. Use of automated tools. Particular automated tooling can be easily identifiable, e.g. using the value of user agent headers or the speed of requests. This can indicate that an attacker is using automated tooling. Common payloads. In web applications, it's common for attackers to use known payloads. Detecting the use of these payloads can indicate the presence of someone conducting unauthorized malicious testing on applications. Just detecting suspicious activity isn't helpful. This suspicious activity needs to be rated according to the impact level. For example, certain actions will have a higher impact than others. These higher impact actions need to be responded to sooner, thus they should raise alarms to get the relevant party's attention. Put this knowledge into practice by analyzing the provided sample log file. You can download it by clicking the Download Task Files button at the top of the task. What IP address is the attacker using, and what kind of attack is being carried out? Let's go ahead and download the task files. Okay, save that. We don't need this anymore. Cat login. Unauthorized 401. So this is the IP address that the attacker is using, most likely, because these are unauthorized login attempts. And they're trying different usernames: admin, administrator, anonymous, and root. This is gonna be brute force. Okay. Moving on to task 22, number 10, and the final web app vulnerability on the OWASP Top 10 2021 list. We have SSRF, or server-side request forgery. This type of vulnerability occurs when an attacker can coerce a web application into sending requests on their behalf to arbitrary destinations while having control of the contents of the request itself. SSRF vulnerabilities often arise from implementations where our web application needs to use third-party services. Think, for example, of a web application that uses an external API to send SMS notifications to its clients. For each email, the website needs to make a web request to the SMS provider's server to send the content of the message to be sent. Since the SMS provider charges per message, they require you to add a secret key, which they pre-assign to you, to each request you make to their API. The API key serves as an authentication token and allows the provider to know to whom to bill each message. The application would work like this. So we have the web application on mysite.com. There is the using the SMS API. There's a server parameter, and we're setting that to srv3.sms.thm and the message to hello. We send the SMS, so the request gets sent via a GET request. It goes to mysite.com, builds the query with the API, and then forwards that to the SMS provider using the API key. By looking at the diagram above, it is easy to see where the vulnerability lies. The application exposes the server parameter to the users, which defines the server name of the SMS service provider. If the attacker wanted, they could simply change the value of the server to point to a machine they control, and your web application would happily forward the SMS request to the attacker instead of the SMS provider. As part of the forwarded message, the attacker would obtain the API key, allowing them to use the SMS service to send messages at your expense. To achieve this, the attacker would only need to make the following request to your website: https://www.mysite.com /SMS server equals attacker.thm and message equals ABC. This would make the vulnerable web application make a request to attacker.thm/API/send and message equals ABC. You could then just capture the contents of the request using netcat. So we set up a netcat listener on port 80, and we are able to capture the request. This is a really basic case of SSRF. If this doesn't look that scary, SSRF can actually be used to do much more. In general, depending on the specifics of each scenario, SSRF can be used for enumerating internal networks, including IP addresses and ports, abusing trust relationships between servers and gaining access to otherwise restricted services, interact with some non-HTTP services to get remote code execution. Let's quickly look at how we can use SSRF to abuse some trust relationships. Practical example. So we're gonna go to the web application on port 8087. Explore the website. What is the only host allowed to access the admin area? Page source. Image inside where it reveals when clicked on menu icon. Page content. Header portfolio section. Grid for photos and photo grid. Portfolio section, about section. So we can download a resume. Not too interesting. Home, portfolio about contact. Oh, we have admin area. That's what we want to look at. Oh, admin interface only available from localhost. Okay. Check the download resume button. Where does the server parameter point to? If we hover over this, we can see the server parameter points to secure-file-storage.com. Secure-file-storage.com. Using SSRF or a server-side request forgery, make the application send the request to your attack box instead of the secure file storage. Are there any API keys in the intercepted request? So let's set up a netcat listener first. Netcat tag LVNP. Probably can't run it. Oh, we can run it on port 80. Okay, there's nothing running on port 80. Using SSRF, make the application send the request to your attack box instead of the secure file storage. Are there any API keys in the intercepted request? Okay, so admin area. Let's copy this link. And then we'll replace this. With our VPN IP. Maybe more we need to do. Oh, nope, that's all I needed to do. That's server-side request forgery. We have the API key, which is also the flag. Submit. Going the extra mile. There's a way to use SSRF to gain access to the site's admin area. Can you find it? Note, you won't need this flag to progress in the room. You're expected to do some research and search in order to achieve your goal. So I need to make the web server think that we are running as localhost. And how do we do that? I don't think we can just do localhost. Connection refused. how do we do this? Let's go to the original. Copy this link again. Well, I'm gonna have to go ahead and stop the stream there because I have an appointment soon. So, yeah, we're gonna go ahead and end it there. Thanks everyone for joining. I really appreciate it. Hopefully you learned something new or you enjoyed the stream. Hopefully you come back next time. I'll be streaming again on Thursday from 3 to 5 Central Time US. It's on my schedule. You can find it there to see it in your time zone to make it easier. But I'm gonna go ahead and head out. Thanks everybody.